We humans are a curious species. We look up at the night sky and don't just see twinkling lights. We see other suns, other worlds, other possibilities. This drive to understand, to assemble a complete picture of the cosmos, is one of our most defining traits. It's what pushed us out of the caves and onto the moon. We yearn for a grand theory of everything, a single elegant equation that can explain every star, every particle, every thought. It's a noble quest, born from a deep-seated desire to find our place in the universe and to feel the solid ground of certainty beneath our feet. We want the full story, the ultimate answer key to reality. But what if the universe, by its very nature, resists being fully known? What if the map can never be the territory? Imagine a simple barrel filled to the brim with water. To you, it's just a barrel of water. Now let's add a single grain of sand. Has the barrel of water changed? Objectively, yes. Its mass has increased slightly, its volume has shifted infinitesimally. A new object now resides within its boundaries. Yet, for all practical purposes, it remains a barrel of water. This tiny, almost imperceptible change highlights a fundamental challenge. Our universe is a continuum of interconnected events, not a collection of neatly separated things. The problem is one of scale and interaction. That single grain of sand, while seemingly insignificant, is now part of the system. It displaces water molecules, it adds its own gravitational pull, however minuscule, and it changes the overall chemical composition. Now, imagine trying to describe the barrel of water perfectly. To do so, you would need to account for every single water molecule, every dissolved mineral, every quantum vibration, and yes, that one grain of sand. An absolute description would require you to track an almost infinite number of relationships. The moment you try to capture it all, the system has already changed. Absolute knowledge demands a freeze frame of a universe that never ever stands still. This humbling reality doesn't mean we should give up. On the contrary, it makes the pursuit of knowledge even more thrilling. It means there will always be another layer to peel back, another mystery to investigate. Our quest for understanding is not a journey to a final destination called truth. It's an infinite voyage across an endless cosmic ocean. The horizon of knowledge expands as we sail toward it. The desire to know everything is the engine of discovery, but the acceptance that we can't is the beginning of wisdom. It keeps us humble, it keeps us searching, and it keeps the adventure of science alive for generations to come. So, how do we even begin to make sense of this infinitely complex, interconnected cosmos? We do what humans do best: we simplify. Science is the most powerful tool we have for this. It works by drawing lines, creating categories, and isolating small, manageable pieces of reality for study. We have biology for living things, chemistry for their molecular interactions, and physics for the fundamental forces that govern them all. We invent these disciplines to focus our attention. We put a frame around a tiny patch of the universe so we can study it with incredible precision. This method is spectacularly successful. It's given us medicine, technology, and a profound understanding of natural law. But we must never forget that these divisions are our own invention. Nature itself does not have departments. There is no line in the ocean where physics ends and biology begins. A star isn't just a physics problem. It's a crucible of chemistry, a generator of energy that can spark biology light years away. When we study a cell, we might call it biology, but we're also witnessing a symphony of chemical reactions governed by the laws of quantum physics. These categories are like the lines of longitude and latitude on a globe, incredibly useful for navigation, but you won't find them etched into the surface of the Earth. They are tools for our minds, not features of the world itself. Think of it like trying to understand a magnificent painting by examining one square inch at a time. You could become the world's leading expert on the specific shade of blue in that single patch. You could analyze its chemical composition, its texture, and the way light reflects off it. You would learn a great deal. But you would know almost nothing about the painting as a whole. You would miss the artist's composition, the emotional weight of the scene, and the story it tells. Science, by its very method of focused inquiry, must temporarily ignore the rest of the canvas to understand the brushstroke. The power of science lies in this focus, but its limitation is built into the same process. This process of selective attention is not a flaw in science, it is a necessary feature. To build a model of a weather system, you can't account for the flutter of every butterfly's wings, even though we know in principle that they are part of the same dynamic system. We have to filter out what we deem to be noise to see the signal. We create a simplified, idealized version of the world in our laboratories and on our computers. This gives us immense predictive power, but it comes at a cost. The cost is that our knowledge is, and always will be, an approximation, a brilliant and useful sketch, but never the finished masterpiece of reality itself. The limits of knowledge aren't just a practical problem of managing complexity, they are woven into the very fabric of logic and language. In the 20th century, two brilliant thinkers, a mathematician and a philosopher, helped us see these limits with breathtaking clarity. The mathematician Kurt Gödel delivered a seismic shock to the world of logic with his incompleteness theorems. He proved, with mathematical certainty, that in any formal system complex enough to include basic arithmetic, there will always be statements that are true, but can never be proven to be true using the system's own rules. Think about that. It's not that we haven't found the proof yet. It's that no proof is possible within that framework. Gödel's discovery is like finding a secret room in a house that has no door. You know it's there, but you can't enter it using the building's blueprints. This means that any attempt to create a complete and consistent theory of everything is doomed from the start. No matter how sophisticated our mathematics or how powerful our physics, if that system is consistent, it will be incomplete. There will always be true things about the universe that lie outside the grasp of our equations. This isn't a statement of failure. It's a fundamental property of logic itself. The universe, it seems, will always be richer than any formal system we can devise to describe it. Then came the philosopher Ludwig Wittgenstein, who explored the limits of language. He famously concluded, "Whereof one cannot speak, thereof one must be silent." He argued that our language creates a picture of the world, but the picture has a frame. Language can describe facts, objects, and relationships within the world, but it struggles to describe the frame itself, things like ethics, beauty, and the very meaning of existence. These concepts aren't nonsense. They are simply outside the boundaries of what language can state as a matter of fact. They are shown, not said. The meaning of a symphony isn't in the list of its musical notes, it's in the experience of hearing it. Both Gödel and Wittgenstein in their own ways pointed to the same profound conclusion. Every system, whether it's made of mathematical axioms or human words, has built-in limits. It draws a circle around what can be known, proven, or said. But reality is not a circle. It has no edge. This means that our scientific models, our philosophical arguments, and our grandest theories will always leave something out. There's always a ghost in the machine, a truth that the system can't capture, a beauty that the description can't contain, a part of the whole that slips through the net of our understanding. So where does this leave us? If absolute knowledge is a mirage, is the pursuit of it pointless? Absolutely not. Recognizing the limits of knowledge is not a surrender. It's a promotion to a higher level of understanding. It allows us to use our scientific tools with both power and humility. We can celebrate the incredible successes of science, from vaccines to space telescopes, while acknowledging that they provide a powerful but partial view of the cosmos. The wise approach is to accept our systems and models for what they are, our best maps of reality, constantly being redrawn and improved, but never to be confused with the territory itself. This perspective changes the very goal of science. The purpose of a scientific inquiry is not to arrive at a final, unshakable answer that closes the book on a subject forever. The true purpose of science is to ask better, deeper, more sophisticated questions. A good experiment doesn't just provide an answer, it reveals a dozen new mysteries we hadn't even thought to explore. The discovery of the atom didn't end physics. It opened up the entire universe of quantum mechanics. The discovery of exoplanets didn't just tell us other stars have worlds. It forced us to ask, are any of them like Earth? Are any of them home? Embracing this spirit of inquiry means resisting the temptation of dogma. Whenever someone claims to have the final answer, to possess a system that explains everything, a healthy dose of skepticism is in order. The universe has proven, time and again, to be more subtle, more strange, and more magnificent than our imaginations. The moment we think we know it all is the moment we stop learning. The most beautiful and honest statement in science is not "I know," but "I wonder." It's that sense of wonder that fuels the entire enterprise and keeps the cosmic adventure going. Let's carry this cosmic perspective with us. Let's be explorers on an infinite sea, using our charts and compasses to navigate, but always with our eyes on the horizon, excited by what lies beyond our current understanding. Let us be bold in our questions and humble in our claims. The story of the universe is the greatest story ever told. And the best part is, it has no final chapter. The quest for knowledge is not about arriving at an endpoint. It's about the journey itself, a perpetual, awe-inspiring and deeply human voyage into the unknown.